Morning, everybody. How you doing? Today I want to talk about this architectural diagram that you see in front of me. This is a Python application. So before we get started, let me run the app and show you what it does. Okay, so we have a menu. It displays a menu. And essentially it's a household inventory application. And some of the items are implemented, like number 1's not implemented, number 2, 3, and 4 are implemented, and then number 5 is not implemented. This project is like a template example that you can build upon. And some of my students probably will use it as a framework for one of their projects, right? So it kind of gives an example of how to do this type of architecture. So you're presented with please enter a number, right? So I'm going to list inventories. Okay, so it gives you a list, right? There's one inventory, obviously, in the data store. And I'm going to press any key to continue. And then I'm going to select an inventory. Okay, so here you select an inventory, and then it makes sure that you want to select that one. If you say no, it will go back and redisplay, okay? And then you pick another one. I could clear the screen. I didn't do that. I should change that code. So I'm going to hit 1, and then once that's correct. And now I'm going to list the inventory items now that I've selected the inventory. And that's it, okay? So the rest of the functionality needs to be implemented, at least from the main application standpoint. So then 6 exits. Let's talk about how this application works. Okay, before we dive in deeper, I just want to kind of review my development tools I'm using. I'm developing on a big old Mac Pro, kind of an older one, okay? And I'm running the MySQL database for this example in MAMP Pro. You could use regular MAMP or just install MySQL database. I like MAMP because it runs Apache and PHP-MyAdmin. Okay, so we're going to be using PHP-MyAdmin as well. Let me pull this away. There's my terminal. This is Visual Studio Code. And then behind that, I have PHP-MyAdmin. Now, the database we're hitting is this home inventory database. It has 2 tables. One's called inventories, and it has 1 row in it. And the other one is called items, and it has several rows, and they're all linked to the one row of the inventories table with the foreign key relationship. I'll pull that out of the way and bring this diagram back. All right, so you saw the program run in the intro. Essentially, the architecture demonstrates a kind of a clean architecture where you're attempting to separate concerns for different layers of the application. So let's take a look at the code here, side by side a little bit. Well, a little bit more. Okay, so the main entry point, so the user launches the application. You saw me launch the application. I'm actually using pipiv. So I'm running it with a build script so that when you type ./build.sh, I'll put a link to the project in the description below. It calls, it's running the bash build script, and it's calling pipiv run, main.py. Okay, so when you launch the program, you're actually launching this class. You're running this file right here, main.py. Okay, so let me open this one up. Now, and let me make the text bigger. I hate it when text on YouTube videos are really tinkies, small. Okay, so I think that should be big enough right there. And let me close that Explorer window. So all the main does is provide a main entry point for I like to do my apps this way. It's for Python developers, this will look familiar, right? If underscore name equals main, right? Then that means that this is the main module that's being executed. Call the main function, and then it's importing the inventory app, and it's importing the date. Although I see that I'm not even using that, I could actually comment that out. So in the main method, we're creating an instance of the inventory app, and then we're just calling start application. Okay, so I can close that. And at that point, we're here. I'll slide this over this way just a little bit more. So the main entry point calls the inventory app class, or creates an instance of the inventory app class, which is in the inventory underscore app.py module. Now this functions as the app class functions as the presentation layer. And this orange, dark orange diamond and the line is, that's UML, right? Usually it's a black diamond. Since I have a blue background, black didn't show up too well. So this really just indicates that the main.py module contains, right, or uses the application, the inventory underscore app, right, module. There's a dependency there. And so it's creating an instance of the inventory app class. Okay, so that's why I have this containment, which in this diagram represents anytime you contain something and you call a method, you have a dependency on that class, right, or on that object. And so that's just what I'm trying to indicate here. So we're calling the start application method on the class in here, which is the inventory app. And then the inventory, just its function is to provide a user interface. It's what's drawing the menu. It's what's enabling you to make choices. Okay. However, it has a dependency on the business logic layer. So let's take a look at that class. Actually, let's take a look. I'm kind of skipping. Let's take a look at the presentation layer. Okay. And that is the inventory app. And let me close that down. So we come up here to the beginning, and essentially it's importing, right, the business logic class from the business logic module. I'm also using pretty table, which is how you get those tables when you display the data in the application. That's a great package for that purpose. And then import OS. Now, class inventory app, the .com in here, I'm just saying it implements the control features of the class. So we initialize the object. I have some of these constants here to represent menu choices, so you don't have to remember what 1, 2, 3, 4, 5, and 6 are. And then menu choice is set to 1. Keep going is true. And self.business logic, that's where I'm actually creating the instance of the business logic class. And then active inventory ID is 0. So then I have this clear screen method, and I implemented it this way because for the most part, we'll be running this in a bash environment. Even on Windows, you use Git for Windows, and it provides a bash terminal. So clear should work most of the time. However, if that doesn't work and you're running it in a different environment than Unix-like terminal, then the clear screen CLS should work. Okay. And then I have the display menu function or method, and it just throws up the text for the menu. And then process menu choice, I'm using a match statement, kind of like a switch. I prefer to use it. I like using it that way, right? It's probably not the way it was intended to be used, but it sure makes it nice. Okay. And then, when you make a menu choice, it just calls the corresponding method. So new inventory, list inventory, select inventory, list inventory items, etc. And then I have the methods for each of these. So if you were to select something that doesn't work, it would print out a message that says, hey, this method is not yet implemented. Please press any key to continue. Okay. And then list inventories is implemented. So you come in here when you call list inventories, which is number 2 on the menu item. Clears the screen, if the debug, which it is, flag is enabled, then you print inventories method called. This is just for tracing when you're developing. And then it prints the inventory list self underscore get inventories. Okay, this is a utility method located down later in the class, and it's going to fetch the inventories from the data store. It doesn't care. It's using the persistence layer. It doesn't care where it's getting the data from. It's just using the persistence layer. Okay, and then press any key to continue. So these methods, right? They're there. I don't have to go through every one, but the important thing to note is the inventory app module is dependent on, let's go back to the architectural diagram, the business logic layer. Okay. So now let's go take a look at the business logic layer. So I'll shut that down, open up this, and take a look at business logic. Now, like I say, the whole purpose of the presentation layer is to just provide the user interface. This could be a graphical user interface. This could be a curses interface. In this particular implementation of it, it's just, streams, right? Like terminal input output, nothing fancy. Okay. I think it's easier. It's more, there's more code involved with a graphical user interface, but a graphical user interface is so much nicer, right? But this demonstrates the point. It doesn't really matter. The business logic wouldn't change, right? Like if you had a graphical user interface, it would be calling the same methods. So we're taking a look at the business logic layer at this point. So up here at the top, I was importing this, but I don't need to import this anymore. I could even delete that. I'll leave it there for now. But from the MySQL persistence wrapper. Now, so there's a dependency, obviously, from the diagram in business logic on the MySQL persistence wrapper. That's okay. However, you could use a factory pattern, which in my next video, I think I'll implement a factory class that will allow you to break that dependency between, like having to name your persistence wrapper. Something, you're going to have to signal something, right? So for example, there's going to have to be something that you do in your code that says, I want this type of interface or this type of an object to store my data. Now, as long as it conforms or implements or satisfies the contract defined in the persistence wrapper interface, which we'll talk to, which is this abstract class up here to the right in the diagram, right? As long as this subclass satisfies that contract, it doesn't matter to the business logic layer which of these objects is being substituted, okay? And we'll get into that here in a second. So back to the code for the business logic layer. Really, it just, when it cranks up, it says, yep, I'm going to create an instance of this MySQL persistence wrapper. And like I said just a second ago, we could get rid of this dependency and really just depend on this class, the persistence wrapper interface, right? If we had a factory pattern, we can just like say, hey, give me this type of an object and say, I want for an MySQL database, okay? And then the factory pattern would return that object, and all you'd have to do is test to make sure that it satisfied the interface that this abstract base class defines. And the way Python is, right? If it looks like a duck, walks like a duck, it is a duck. So the duck typing really doesn't, you don't have the same type of interface control, although it's evolving kind of in that direction, Python languages, as you do in like C++ and Java and C#, right? Sometimes developers in those languages are spoiled because of that ability to statically check their types, right? But you can come very close with Python, and I love Python. It's really nice. Okay, so then we just have like get all inventories, and so essentially, this is the interface that your application is going to use. So whatever you want to do from an application standpoint, you do it in the business logic class or the layer, right? Which can contain more than one class in big applications. This represents a layer in this diagram, business logic layer. I named it layer because it represents the layer of the architecture between the presentation layer and the persistence layer or wrapper, right? That this could be a persistence layer as well. However, the layer could contain one class or one module, as in this case, or it could contain multiple. Okay, just throwing that out there. And essentially, whatever methods are required by the front end to satisfy the requirements of the front end are implemented in the business logic class. Okay. Now, the next and most important, I think, aspect of the architecture is this persistence wrapper. So in other words, in this diagram, we're hitting a MySQL database, but you don't have to hit a MySQL database. As long as, the business logic layer is going to depend on the methods implemented by this abstract-based class, and because the MySQL persistence wrapper class extends the persistence wrapper interface class, you're going to have there's a contract there. So let's take a look at how that contract looks. So I'm going to close down the business logic, and I'm going to move to the, let's start with the persistence wrapper interface first. All right, here we are in the persistence wrapper interface. Let me close this down. Oops, close it down. All right, so the contract is this. I have these abstract methods in here. First off, class persistence wrapper interface extends ABC. ABC is the abstract base class package, and abstract method, which is a decorator. So you see the decorators down here on these methods. So none of these methods are implemented, right? They're documented from a contract standpoint. So let's take a look at the contract. Because, in Python, right, unless you have a package that's doing some checking on the return types and checking on your parameters that you're feeding the methods, it's like the Wild West when it comes to like what you might be getting, right? So it's nice to have a contract, and that's what an interface is, right? It's a contract. But because we don't have the types specified for the return, I'm documenting it here in the doc comments. You could add packages that would make this type return and contract enforcement a little bit more explicit. And I'll do another video on down the road about how to actually do that sort of stuff, right? But for now, I'm just using doc comments to document the contract. So get all inventories method returns a list of inventories. So you're going to get a list of inventories when you call that method. Same for get items for inventory. Returns a list of inventory items for given inventory ID. It doesn't care whether or not it's in a database. It doesn't care if it's in a MySQL database. It doesn't care if it's in a data store. That's the contract, right? So wherever you store it, you're going to return a list, and the business logic layer expects a list, right, of inventory items. And then create inventory inserts a new inventory into the data store. Notice I didn't say database, I said data store. Inserts new item into data store for given inventory ID. Okay, now it's up to you as the implementer of a subclass that sticks it in some other database or some other form like a JSON file to figure out how to do that, with that wrapper class, that instance, or that concrete class or that subclass of this interface. Okay, that's the persistence wrapper, and that's the interface contract. So now let's take a look at the actual MySQL wrapper class or persistence wrapper. Okay, So nothing too surprising here except for all the knowledge of the MySQL database. Let's take a look at the diagram. Is contained in this class. Nobody else knows about the MySQL database. All they care about is, here's what I need for the front end. The business logic layer is providing it to me, and the business logic layer knows that, oh, I'm going to get it from the persistence object, right? And everybody is none the wiser in the front end, as long as the front end's getting what it needs. So here we go. So I'm importing the persistence wrapper interface because the class MySQL persistence wrapper extends the persistence wrapper interface. And then in the init method, I have some constants. Now, not all the methods. So the difference between Python and let's say C#, right? If I still had methods that were not implemented, then I would have, this would still be an abstract class, right? But I don't have any adornments on the non-implemented methods. So I'm creating an instance of this class, and we'll see which ones are not implemented. And again, the reason why they're not all implemented is because students may use this particular code as a framework for a project, and they need to then flesh out some of these functions, right? Okay, so database configuration. So anyway, constants for the queries. So select all inventories is a string. Select ID, name, description from inventories. Insert, which is not being used in this case, or in this class because it's not implemented, but the constant for the string or the query is insert into items, inventory ID, item count, values, and then this is like a stored procedure, right? You got to supply the values. And then select all items for inventory, which is implemented. Select ID. Now, I don't like to do select star, right? I like to know what order I'm getting these things back from, right? So select ID, inventory ID, item count from items where, let me scroll this out a little bit, where inventory ID equals blah, inventory ID, okay? And of course, you could probably use more if necessary. And then the database configuration constants, which is just a dictionary, right? Now, this is hard-coded into this class. It probably should be, in a real-world application, it should be off in a configuration file someplace, right? I'm not dealing with that issue at this point. So anyway, I'm just setting, here's the name of the database, here's the name of the database user, there's the host, here's the port. If you're running this on Windows and you're hosting, or Linux, right, you're going to want to check the port number that MySQL is running on. That's about the only advice I could say at this point. Otherwise, if you've got pipiv installed and you got the proper version of Python installed and you got your SQL database running, then this code should work as long as you run the scripts to create the database and insert the data and the tables, etc., and you got the right port number, then you should be good to go. And then finally, the database connection, I have a utility method called initialize database connection using the database configuration dictionary. So and I'll get to that in a second. And then get all inventories, that's one of the methods, and of course it says returns a list, right? That's the contract of all rows in the inventory table. And now at this point, returns a list, that satisfies the contract for the interface. And now we get specific, all rows in the inventories table, right? Cursor none. So all this stuff is very specific to whatever database you're using or that this class hits, right? And then we say get items for inventory ID, same thing. Returns a list of all items for given inventory ID. And then create inventory, pass, not implemented. And then create item, also too, not implemented. That's a pass, right? And then initialize database connection. I'm actually creating a database connection pool, right? So the name of the pool is DB pool, and the pool size is 10 connections. And then I pass in that configuration to enable that connection. And then, of course, everything is try, except, It's not 100% bulletproof, but it works fairly well, right? As long as you got everything configured. And that's, honestly, that's about it, right? So, improvements can be made to, it's not supposed to be like the end-all to be-all inventory application. It's a demo. It's like a learning tool. I would use a factory pattern to break the dependency even more between the actual persistence wrapper class that's required by the front end and be able to just name it like, oh, I want a MySQL persistence wrapper. So you would have multiple persistence wrapper classes available perhaps, right? And that would be a good project to work on to get to that point. So anyway, I hope you enjoyed this video. I hope it was helpful. And if you have any questions or concerns, just reach out to me, Rick at pulpfreepress.com. Visit my website, pulpfreepress.com. And anyway, thank you very much for listening. Have a great day, and I'll talk to you later.